How DNS actually works. When you type a website name into your browser, nothing on the internet actually understands those words. Computers don't recognize language, brands, or familiar names. They only understand numbers. Every device connected to the internet is identified by a numerical address, called an IP address, and that address is what computers actually use to find each other. DNS exists to translate between these two worlds. It turns human-friendly names into machine-readable locations. Without DNS, using the internet would mean remembering long strings of numbers instead of simple names, which would make everyday browsing almost impossible. When you press enter, your computer doesn't immediately connect to the website. First, it asks a question. What is the IP address for this name? That question does not go to a single global database. There is no master list of all websites. Instead, DNS is built as a hierarchy because no single system could realistically store, manage, and update the entire internet. The process starts locally. Your computer first checks its own memory to see if it has already looked up this name recently. If the answer is there, the process ends immediately, without contacting anything else. If not, your computer sends the question to a DNS resolver, usually operated by your internet provider or a public DNS service. This resolver acts on your behalf. It doesn't search randomly. It follows a structured path. The resolver also checks its own cache, which may already contain the answer from a previous request made by someone else nearby. If the answer still isn't found, the resolver begins navigating the DNS hierarchy. It first contacts a root server. Root servers don't know the address of every website, and they're not meant to. They only know where to find information about top-level domains, such as .com, .org, or .net. In other words, they don't give answers. They give directions. The resolver then contacts a top-level domain server, which knows which authoritative servers are responsible for specific domain names. Once again, the response is not the final answer, but another step closer. Only after this does the resolver reach the authoritative DNS server. This server holds the official record for that name. It contains the IP address, or sometimes multiple IP addresses, associated with the website. This is important. Many websites don't live in one place. They use multiple servers, often spread across different regions of the world. DNS can return different IP addresses depending on location, load, or availability, allowing traffic to be distributed efficiently. From the user's perspective, nothing changes. You type the same name. You reach the same site. Behind the scenes, DNS quietly helps route you to a suitable server. Once the resolver receives an answer, the journey reverses. The IP address is sent back to your computer, and the result is stored temporarily. Your computer stores it. The resolver stores it. Sometimes even browsers or applications store it. Each stored answer comes with an expiration time. This tells the system how long the information can be reused before it must be checked again. This is why DNS is fast most of the time. Most requests never reach the root or authoritative servers. They are answered locally, long before that. But this also explains why DNS changes don't always take effect instantly. If a website moves to a new server, older answers may still exist until their expiration time passes. The system isn't broken. It's respecting the rules it was given. DNS is also designed to be globally reliable. When you contact what appears to be a single DNS server, you're often reaching one of many identical servers distributed around the world. Your request is routed to the nearest available one. If a server goes offline, another takes over automatically. This design prevents large portions of the internet from failing due to a single problem. Despite how critical it is, DNS remains deliberately simple. It doesn't verify content. It doesn't check security. It doesn't know whether a website is trustworthy. It only answers one question. What number belongs to this name? Everything else happens later. All of this usually happens in milliseconds, so fast that it feels instant. You only notice DNS when it fails. When a website can't be found, the internet didn't disappear. The translation step did. So when you type a website name and press enter, you're not really asking for a page. You're asking a global, distributed system to translate a human idea into a machine location, using a structure that has quietly scaled with the internet for decades. DNS doesn't show you the internet. It tells your computer where to begin. And that's how DNS actually works. Thanks for watching. Did you already know this is how DNS works? Or did something surprise you? If there's another everyday system you'd like explained, Let me know in the comments. And if you liked the video and the way I explained things, please subscribe. This will really help me and the channel to grow. Till next time.